Okay, so in this question, we're asked to sketch a right triangle corresponding to the trigonometric ratio of the acute angle theta. Here it is. Cotangent of theta is equal to 3, right? This is our corresponding trigonometric ratio. And we want to use Pythagorean theorem to determine the missing sides and then find the other 5 trigonometric functions of theta. So, all right, let me sketch a right triangle here. Let me do my best impression of a right triangle. That looks pretty right triangle-y, don't you think? All right, so let's deal with that one here. Get my pen to work here. There we go. Let me make that a little bit more nice. All right, there we go. Nice. So let's deal with our. Come on, pen. There we go, pen. Some angle theta. We'll call the angle theta right here, and we remember that cotangent is the ratio adjacent over opposite. Well, if it's 3, that is a ratio. We don't really state it this way often, but 3 over 1, right? So that means that our ratio right here is that the adjacent side would be 3 and the opposite side would be 1. Now, actually, that's just the ratio. It could have been 6 and 2 or 30 and 10 or 300 and 100 or something else. As long as the ratio of the two sides was 3 to 1, we're in the right ballpark. So if we're just interested in the ratios, we don't have to know the exact numbers at this point. But we do need to know our hypotenuse. So how do we get our hypotenuse? Well, we're going to use the Pythagorean theorem. The Pythagorean theorem would state that we take the square of the two legs of our right triangle, so 1 squared and 3 squared, add those up, and that's going to give us the square of our hypotenuse. Well, 1 and 9, that's 10, is the square of our hypotenuse, and so our hypotenuse in this case is going to be square root of 10. All right, so if we're interested in our other trigonometric ratios, let's work them out. When we say sine of the angle theta, what do we mean? That's right, opposite over hypotenuse, 1 over the square root of 10, which we're going to rationalize and make that square root of 10 over 10. The next thing we're going to look for is our cosine of the angle theta. So cosine of the angle theta is equal to our adjacent over our hypotenuse, so 3 over the square root of 10. That's going to be 3 times the square root of 10 divided by 10 when we rationalize that denominator. Our tangent of the angle theta is opposite over adjacent, so that's simply 1/3, and that's fine. That's the way we'll leave it. Our other trigonometric functions, well, let's see. We have our reciprocal for sine, which is cosecant of theta. Cosecant is hypotenuse over adjacent. We could write that as square root of 10 over 1, but we're just going to leave that as square root of 10 when we simplify it. And then, of course, the reciprocal of cosine would be the secant. So we would say that the secant of theta is equal to the square root of 10 divided by 3. And there's nothing else we can do with that. So these are our 5 trigonometric ratios, the ones that we didn't have before, along with the missing side. That's what we wanted here in this example. Now, here's an additional question. We have a right triangle that contains an angle of 20 degrees. And it has a hypotenuse with a length of 10. Right? So here's our situation. We've got this 20-degree angle and our lengths of 10. What are the lengths of the opposite adjacent sides? Do we have enough information to find that out? Well, yes, we do. And the reason that we have enough information here is that we're dealing with an opposite and an adjacent side in a triangle in which we already know the angle. And so if we recognize the fact that, for example, if I were to take the sine of that 20-degree angle, I'd be getting the ratio of the opposite to hypotenuse side. And I already know what my hypotenuse side is, right? So let's say that my opposite side, we're going to call that y. How would we find it? Well, if we say that the sine of 20 degrees is equal to y divided by 10, then y, that opposite side, is going to be 10 times whatever I get from the sine of 20 degrees. Now, if I work that out with my calculator, I get approximately 3.42. And let's call the adjacent side x. How should we handle that? Well, we know that the cosine of 20 degrees is going to be found by taking the length of the adjacent side over the hypotenuse. So I can use that fact to help me find that the cosine of 20 degrees is going to equal x over 10. So a simple multiplication tells me that x is equal to 10 times the cosine of 20 degrees this time. And if I work that out on my calculator, I get approximately 9.40 as the length of my adjacent side. Well, this is an incredibly useful thing, and we'll be employing that with some applications soon.